Hello, everybody, and welcome to The Gist, a limited podcast series powered by Energy Central covering the big, bold, and impactful technological developments in geospatial information systems that are permanently altering the modern power grid. I'm Energy Central Community Manager and your host for this series, Matt Chester. Over the course of the last several weeks, we've covered a ton in GIS, renewables, the utility network, data management, and so much more. But really, that's only the tip of the iceberg. Understanding GIS to its full extent means understanding that we're only just getting started. The thing about technological advancements, after all, is that they just keep coming. So today, we're taking the time to explore where we go next. What is the future of GIS? And how can utility leaders prepare for that future effectively? As our grid and the ways we interact with it change at warp speed, we want to be prepared. And that's what today's conversation is all about. We'll talk about how GIS is powering a future focused on the big three: reliability, resilience, and affordability. We're talking about the next gen tech that'll bring us unique ideas and new opportunities. And we're talking about how utilities are rising to the occasion to make the most of what lies ahead. I'm pleased to welcome our guest today, Dr. Comfort Manyame, a geospatial technology leader, strategist, mentor, and the current director of geospatial R&D at EMPACT Engineering. Dr. Manyame, welcome to The Gist.
Thank you, Matt, for having me. It's quite an honor to be here and just get to talk to you.
We're thrilled that you took the time to do so. So let's start with some basics. Can you tell us about your work leading geospatial R&D at EMPACT? What exactly does that entail, and how long have you been focused on geospatial technology?
So, I'll start with maybe how long I've been involved in geospatial technology, and then get into the ins and outs of impact engineering, what we do, and what my role is there. So I've been involved in GIS in one way or the other since the late 90s. That's how old I am. So since the late 90s, and if you're familiar with Esri, right? So at that point, Esri, they had this command line Arc-Info software. That was the GIS at that time, So that's really where I started. And then saw that development and evolution of Esri from Arc-Info to ArcView, and then ArcMap, ArcGIS Online, ArcGIS Pro. So I've kind of seen all that over the years. So I've been involved in GIS, for at least 20 years, 25 years. Mostly as a user, I think the first part of my career really just as a user. And then later on as a strategy, as a strategy guy, and then just research and development, which is what I'm involved in right now. So Impact Engineering, we are an engineering consultancy firm that does mostly design work for distribution utilities. We do work in joint use, so communications. But lately, we've also been doing a lot of building digital twins for utilities and doing vegetation management for utilities as well. So a lot of my work right now is focused on vegetation management. But overall, when I think of my role at my organization, I would like to think of myself as, somebody that's there to challenge the status quo, right? So what are we doing in terms of geospatial mainly, and what can we do better? So not just for my organization, but for our clients, so for electric cooperatives for the most part, where technology kind of moves at a slower pace than a lot of other industries. So I'm constantly trying to challenge, how we do things, and looking for opportunities to improve the processes that we have in place currently. So that's, in a nutshell, I think that summarizes what my role is.
Yeah, no, that's terrific. And you mentioned, how long you've been working on this kind of from the early days. So, no doubt the technology, it's evolved a lot over those 25 years. Can you highlight for us what maybe some of those biggest changes to GIS technology has been over that time?
The biggest change for me really has been, that transition from desktop GIS to now, web apps and just cloud, cloud native geospatial. That's been the biggest change, and with that came also an improvement in efficiency, an improvement in accuracy, an improvement in the way that analytics are run, right? So imagine, especially in the utility space, right, where I think I've done at least about 12, 13 years in the utility space, just doing geospatial. When you look at utilities, I think where we started, GIS was used mostly for mapping, or for producing static maps. So we would print these maps out, give to linemen, and they would go out in the field, do whatever needs to be done. And if you were data centric, right, the best that you could do is have those guys mark on the map, what work was done, and then they would bring those maps back in the office, and then somebody would digitize all that work into some geodatabase or some database, right? So that's really the extent of what GIS was way back then. And then, of course, we saw that transition from desktop to cloud, or to online stuff, to mobile stuff, where now, instead of guys marking stuff on paper maps, they would actually go out in the field with a mobile device, connected to the cloud, or maybe they would have an offline map, do their work in the cloud and then sync, to the server, and hence facilitate or enable real-time or near real-time analysis, near real-time data capture and updates. So that's, for me, that's really been the biggest change, right? Everything else that has come out of that is a bonus. So, for example, the stuff that's happening now with the integration of GIS and AI, for example, integration of GIS and machine learning, 3D capabilities, I think all this stuff now feeds on the ability that we have now to do geospatial in the cloud, right? Not necessarily local, not necessarily on the desktop. So I think that really summarizes the biggest changes that I've seen in terms of the technology itself. But then also, when you look at the changes that I've seen in terms of utilities, right, using geospatial, the biggest one is, again, coming from that understanding that GIS enables the creation of maps and, so mapping, producing paper maps, to the ability to do analytics, using geospatial data, right? So now you're not just using GIS for visualization, but there's a lot of analysis or a lot of analytics that utilities now are taking advantage of, to improve their workflows, to improve, reliability, resilience. I know we talked about that, and you talked about that in the intro, right? To say resilience, reliability, affordability. I think now you see geospatial playing, and rightfully so, playing a key role enabling all that when it comes to the utility grid.
Right. Yeah, and that's right on target for, our audience in the power sector on energycentral.com. We spent a lot of time in our recent episodes talking about the ways GIS technology can solve major problems and help utilities build for the future. So I kind of want to zoom in on that a little bit, and some of the aspects that you just mentioned. Can you give us a little bit more of a high level look about how GIS is enabling utilities to create a different and maybe even more efficient future with these opportunities?
The first one that I can think of is, how I like to say that, how smart can your grid be if you don't know where it is, right? So everything is location, 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 location. So we have seen that evolution, or that transition from what we used to call mapping grade, which is roughly about 30 feet, to very precise survey grade locations when it comes to asset locations, right? So now you're talking within a few inches. So that's the first thing. So the accuracy of the data that we're using now, when it's geospatial, has improved vastly, from a few years ago. That enables the grid. Think of emergency response, right? Or even think of something as simple as responding to an outage. If you know where the outage is within, a very good, with very good accuracy, then it improves the time that you respond, and that feeds into the whole resiliency, right? So when you're talking grid resilience, we're saying, if the grid is interrupted, how fast can you respond to that interruption so that you can restore power back? So I see geospatial having enabled, the resilience part of what we talk about, when it comes to the smart grid. That's the first thing. Second thing is, when you think of asset maintenance, asset management, one of the things that a client of ours was doing here in Texas, or South Texas, is, they fall in they serve a service territory that receives a lot of lightning strikes, right? Previously, nobody really thought to make a correlation, or to look at the impact of lightning strikes on asset health, for example, right? But what these guys started doing is they said, okay, we know that there is lightning data that exists. Is there a way that using geospatial, we can analyze these lightning strikes and come up with a map of our service territory that shows lightning density, right? So can we classify our service territory based on lightning density? And then if we can do that, then we can also go a step further and say, the areas where we see a lot of lightning strikes, maybe those are areas that we need to do more proactive, asset inspections, right? Because we know that these assets are being hit by lightning strikes more frequently than everywhere else in the territory. So that's one smart way of doing asset management. The other smart way is now using lightning data, for example. If we have those lightning density maps for the service territory, can that influence or can that inform the way that we design our lights, right? So for example, I think for distribution systems, they install a lightning arrestor, which is just lightning protection, right? So they install a lightning arrestor every quarter of a mile. I'm not 100% sure, but I think it's something like that, right? Every so often you are installing lightning protection. But then if you know that you are in an area where lightning is hitting, say maybe 2 times or 3 times more than everywhere else, instead of installing that arrestor every quarter of a mile, what if you do it every eighth or whatever that number is, right? So improve the frequency of arresters, improve the number of arresters so that you can protect your grid, and hence improve your reliability and resilience. So all these are things that I think now with geospatial, there's a lot of analytics, a lot of spatial analytics that can be done that previously people really never thought of doing things that way. So, and GIS or geospatial technology is enabling all that. So that's just one simple example, by the way. I think there are many that exist out there, that fall in the same space of things that we never really used to think about, as affecting our asset health, asset life. But now with GIS, we can integrate a lot of data sources, run some analytics, and actually come up with a model for asset inspections.
Yeah, no, that's fascinating, because I think when you typically hear about using tools to respond to, let's say extreme weather, it's usually, the major hurricanes or wildfires, and you mentioned, the resilience aspect of that, of knowing exactly where outages are. But something like lightning is a little bit more routine, so it's really interesting to hear that that's something that, Pandora's box is kind of open there with that sort of data. A common challenge when we talk to utilities, just overarching, is in terms of what data they have, who has that data, and how it's being used. And the unfortunate repeated term I hear is it's siloed between departments, where left hand isn't talking to right hand. Do you see GIS helping break those walls down?
Absolutely, because I think when I think of data silos, and the reason why they may exist in other organizations or in some organizations, I think when I think of silos, I really think more, not even from a technical perspective, right? I think more from a trust point of view. I really think that one of the reasons why we have data silos is, of course, apart from just poor data management, I think trust is a big part of it. Imagine if we had data of such high accuracy that can be trusted throughout the organization. Suddenly that data now becomes the single source of truth, right? Or it becomes the authoritative data source that everybody goes to. I think as long as the data is of high quality, so quality here, we're talking the accuracy of the data, we're talking of the currency of that data, we're talking of the completeness of that data, right? As long as that data meets all those 3 or 4 different parameters or measures of quality, I really think that facilitates the destruction of silos, because people now start trusting, that data, and it suddenly becomes the single source of truth, or it suddenly becomes the authoritative data source that everybody goes to. That helps now in destroying those silos. Because again, like I said, I think one of the reasons why you have silos is I can trust my data, and more than I can trust your data, Matt. So I'll have my own copy. I will have my own copy of data, and then you have your own copy of data, right? But if we can agree that this is the authoritative data source and it's of high quality enough to where it helps us to run all the downstream analytics that we need to run and getting, actionable insights or getting good results, I think that helps in destroying those silos.
Yeah, no, and you're talking about building that internal trust in the data, but I have to imagine that also helps with external trust and aspects that utilities deal with every day, like regulatory compliance. Do you see correlation there as well?
Absolutely, absolutely. Because again, when you talk of regulatory compliance, one of the things that I think about is vegetation management, right? So, we talk about right of way. Utilities everywhere, they need to maintain, some right of way of some sort. So transmission greater than distribution, and I think transmission has more regulatory compliance requirements compared to distribution, right? So in the transmission space, for example, being able to maintain that right of way, clear is a big deal, right? It's a big deal because it helps with meeting the regulatory compliance. Now, if you're using high accuracy data, we'll talk about, LiDAR, for example, where you know that your data is accurate to within a few inches, so a couple of inches, that helps in making the case, with regulatory, to say, this is our data source, this is the data that we use. And if you can actually show that data overlaid on your grid and show those distances to survey grade accuracies, that helps, that helps your case. So the more accurate the data is, I think the easier it is to comply with reg. And the other thing, think of endangered species, right? So a lot of times utilities have to go through, it could be, protected national forests or whatever the case may be, where there could be endangered species. Now, if you have good data that shows you the locations of those species, it could be birds, it could be even plant species. If you have good data, it helps you again to not violate, the regulations that are there or that have been put in place to protect, whatever it is that's being protected.
Yeah, no, that shows how it's an incredibly important tool for utilities today. But today's episode, we really want to start looking forward as well. So shifting to that forward-looking mindset, can you talk about how you see GIS continuing to change in the years ahead? What applications do you see the most room for improvement and advancement?
So in terms of change, I think because when you look now, Matt, GIS is everywhere, right? Several years ago, I think GIS used to be restricted mostly to environmental sciences, natural sciences. But really, the truth is, GIS now is very industry agnostic. I think every industry uses location in one way or the other, right? So I think because of that, a lot of the changes that we will continue to see in the geospatial technology space will actually come from demands that are coming from the users, right? So a lot of user demands are going to cause, a shift and a change in the way GIS is not only consumed, but in the way that it's delivered, to the users. So that's the first thing. Because of that, I think we'll see a lot more of, the democratization of GIS, right? To where now we are making GIS applications available to pretty much everybody, right? You don't need to be able to write code, for you to be able to do very sophisticated or very complex analytics, So I see that as a big thing in terms of GIS. That accessibility, making GIS accessible even to people that are not, traditional GIS users, I think it's going to be a big part, not only to how people consume it, but I think it will also be a big part of the success of the geospatial technology industry itself. So that's the first thing. The second thing, again, I think I alluded to it a little bit, where now, geo AI, this whole idea of combining traditional GIS processes, like spatial analytics, geostatistics, even image analysis, combining all that with artificial intelligence and machine learning, so that now you can consume huge data sets and come up with do pattern recognition, do feature recognition, and do some predictive analytics. So that combination of GIS and AI and machine learning, in my opinion, is going to continue to grow. Right now, I really feel that we're scratching the surface. So when you're talking of what industries, for example, do you see benefiting a lot, from this from this improvement or this growth and development in GIS, I really think that the utilities, stand to benefit the most, right? Right now, we're doing a lot of vegetation right now in a lot of work in vegetation management, and what that requires or how we do it is we're using LiDAR data, right? So we're capturing high density LiDAR data. Those are humongous amounts of data, right? Going through all that LiDAR point cloud data to classify it so that you can identify what features are in the LiDAR, and then going even a step further to try and figure out where do you have, vegetation violations, for example, where do you have comms violations, doing things like pole loading. All this is stuff that I think will benefit utilities. I think the utility industry for sure is already benefiting, but it will continue to benefit, from this integration of geospatial data, geospatial technology and other emerging technologies.
Yeah, and so you're highlighting a lot of the new tools that can be built upon GIS, or how AI can be combined with GIS. So this is obviously going to change the specific ways that utilities use those tools in combination. So can you talk a little bit more specifically about what those different applications will look like? What will GIS of the future factor into, let's say, the strategic decision making that utilities make moving forward?
Yes, absolutely. So I think if a utility still considers geospatial data, for example, as just a static, and not something dynamic and a living organism that's evolving and growing, I really think that they stand to lose a lot, right? So which means when you are thinking strategy, when you're thinking, 5-year planning, 10-year planning, there has to be a lot of thought that goes into, again, the emerging technologies that we're talking about, right now, where GIS meets AI, where GIS meets machine learning, where GIS meets cloud computing, right? Where GIS, even now, some of the new technologies that I'm thinking about is even edge AI, right? So we're not even doing the AI on a server somewhere. This is actually happening right on the edge. It's either on a cell phone or on mobile. So I really think that utilities that are forward thinking, they have to make provision in their strategy. They have to make provision, in the way that they plan, for data that is dynamic, for data that is huge. We used to talk about big data, right? Several years ago, but I think that's still a thing, because a lot of the data that's being used now and a lot of the data that will be used in the future to run the kind of analytics that we need to run will be big data, right? So high velocity. So this is data that is changing constantly. This is huge amounts of data. So what does that mean to the IT budget, for example, of an organization, right? What does that mean to the staffing requirements of organization? So when you're planning all these aspects, I really think that are affected by the emerging technologies and that intersection between those technologies and geospatial. Because again, I think the case that I really want to make all the time is that GIS is what enables a lot of what maybe 90%, 95% of the industries are doing. Because everything that we do is location-based, right? And now also when you look at the idea of miniaturization of sensors, right? So we've got all these small sensors now, your phone, your smartwatch, the Internet of Things. All these devices are feeding, almost near real-time, or in some cases, real-time data that can enable analytics, which can provide actionable insights in real time. So I really think that, again, so back to your question of when you're thinking of just the strategic planning of organizations, how I think that is detrimental, to the way an organization works if they are not thinking geospatial for the future, if they're not thinking AI, your machine learning, if they're not thinking real-time analytics, if they're not thinking 3D. So it really becomes important that as they plan, as they strategize, this is one of the key things that they're thinking about.
Yeah, and those keywords of the AI, the machine learning, all of that, it's definitely going to pique people's interests. And I'm curious if we can make it a little bit more tangible. Can you share any specific examples of ways that you've already seen GIS integrated with that and what those outcomes have looked like?
So again, I'll go back to vegetation management, right? Because that's the world I'm living in right now. We capture, we capture LiDAR data using fixed wing aircraft, and that data comes back. We are talking terabytes of point cloud data, right? Of LiDAR data. When we get that data back, if we're doing a project for a client, that's not what we deliver to the client, the raw data. So we have to go through that data. And without AI, right, or without machine learning, where we're training, where we're training models based on this, huge data set so that the machine can pretty much do the work, right? If we're not using AI to classify, those billions of data points, I don't see how we could even do what we do, right? So we're using AI and machine learning algorithms to classify that point cloud. So now we know what is vegetation, what is conductors, electric conductors, what are poles, what is the ground. So we're creating this 3D model basically of the Earth that includes all those different features and all those different types of features that are relevant, say maybe to electric design or to vegetation management. And then so after we do all that, we're still also using AI to run the analytics that allows us to say, give me all the vegetation that is within a certain distance, of my primary conductors or my distribution conductors. And then that's how we create these layers that now we deliver to our clients to say, hey, by the way, these are the locations where you have, vegetation violations, for example, or these are the locations where, you have comms violations. And again, all this is AI, and I think we could not be able to do this without using, some of these algorithms or without using AI to decipher what is in the data and to tell us what exactly is the data.
Absolutely. And that's really helpful. So, Dr. Manyame, as we wrap up today's conversation, I just want to ask if you have any final thoughts to share. We'd love to hear what you have to say, particularly in the form of any advice or insights that'll be useful to our audience of utility professionals who are listening in, and maybe, I don't know, if they're feeling like they're lagging behind or they want to get a head start, what should they be thinking about at this moment in time?
So thanks, Matt. One of the things that I like to say, because I saw this firsthand, is, usually when utilities think of GIS and analytics and things that make a difference in the way that utilities run, we are usually thinking very expensive data sets. We're usually thinking very complicated analytics. One thing I would say is we did some work a few years ago for a utility using freely available data. So what we did is we're looking at the outage situation and we're trying to figure out, and again, this was vegetation related, right? So prolonged drought in Texas, which caused a lot of trees to die. And those trees were close to power lines. And then so they were falling on power lines and causing a lot of outages, right? And damage to the infrastructure. So the utility got so overwhelmed in how to respond to those dead trees. So what we did is using simple analytics, right? So take some soils data, take vegetation type data, take rainfall data, and then the outage numbers or the outage data from the utility, came up with a model that helped us to predict where we thought we could find dead trees in the system, right? So came up with that model that classified their service territory based on tree mortality. Using that map, the utility then proactively sent crews to those locations where we had said you are likely to find dead trees here. And so they did that and cut a lot of dead trees from their system and managed to reduce vegetation-related outages by around 60%. So this is using simple, just simple, freely available data out there. So I guess my point is your data doesn't have to be 100%. The analytics that you're running don't have to be all there. There are minimum things that you can do in terms of analytics and in terms of data that can get you so far, So start somewhere. So I guess my message is start somewhere. Don't wait until you have a perfect system. Don't wait until you have the perfect analytics. Don't wait until you have the perfect data. Start somewhere And then, after you've started somewhere, that little, maybe 10%, 20% that still remains. Now you can fill that with the new technologies. That's my first, I guess, maybe word of advice to utilities. The second one is what we have said before, right? To say, think GIS for the future in everything that you're doing, because it's no longer desktop anymore, right? There's a lot of stuff that's happening in the cloud. So think like that. Think about fast moving data, right? High velocity. Think about analysis on edge, right? So edge analytics. Think about integrating GIS with AI, because there's more value that you get out of doing that. So it's no longer traditional GIS as we used to know it. There's been a lot of advances in the technology. And so keep up with those technology trends when it comes to geospatial, because I think that's where you get the biggest bang for your buck.
Wonderful. Well, that's inspiring and encouraging, and I know it's going to be helpful to our listeners. So, Dr. Manyame, thank you once again so much for joining us today on The Gist. It's been really great to learn more about your work, and we're incredibly grateful for your time.
Thank you so much, Matt, for having me. This has been a pleasure just talking to you and sharing what we're doing.
Terrific. And we also want to thank everybody who's listened to this episode and all the ones that came before it as a part of The Gist. While this will be our last episode of this limited series, we're not going anywhere. So you can catch up on all the episodes of The Gist, plus our other shows on the Energy Central feed at any time. And if you want to stay in the loop on all of our upcoming limited series, epic interviews, and more, subscribe to this feed, share an episode with a friend or coworker, and head to Energy Central for further insights on this technology that's moving the power industry forward. Thank you for listening, and we'll see you soon.